So the problem statement is that there are two languages, L1 and L2, and two genders, male and female, studying. So 13 female students study language 1 and 15 study language 2, and similarly for the male. So language 1 is studied by total 18 people or 18 students, and 32 students learn the language 2. Now the question is, what would be the probability that if you pick two students randomly, then they happen to study the same language, right? Or we could also compute the probability of two students picked randomly and they happen to study different languages, right? So how do we approach this? So you have in total 50 students. So the total sample size or total possible picks, right, possible combinations of two students picked would be 50 C2, right? So there are basically 50 C2 ways in which you can pick two students out of 50 students in total. So that's the denominator, that's the total possible combinations of two students out of the set of 50 students. But 18 of them study the language 1 and 32 study the language 2. So if you pick any two students from those 18 who study language 1, those will be, the two students who study the same language, language 1. So 18 C2 are the number of ways in which you can pick two students out of those 18 studying language 1. And similarly, 32 C2 is the number of ways in which you can pick two students out of the 32 students who are studying the language 2. So the two possibilities, 18 C2 plus 32 C2, is all the ways you can pick basically two students who would be studying the same language, right? So that goes in the numerator, and denominator is 50 C2, right? Two students picked out of the set of 50. So 18 C2 would be 18 into 17 by 2. Right, that's the beauty of, like, if you have something C2, n C2, then you can just do n into n minus 1 upon 2. So easy way to calculate. So you put the values 18 into 17 by 2 plus 32 into 31 by 2 divided by 50 into 49 by 2. You will end up somewhere 0.52. There is another approach of doing the same thing or thinking about this problem. Is first you pick two students studying the language 1. So there you compute the probability, and then you compute the probability of, from language 2. So you pick two students out of those 32 students, right? So the probability would be 18 by 50, like you have in total 50 students to pick from, and you pick any of the 18 students, right? If you want from the language 1. And then once one student is picked, there are only 17 students left of the language 1, right? So 17 upon, and total students will be 49. So 18 by 50 into 17 by 49 would be the probability that you pick from the language 1, right? Plus the other language, right? If you want to pick two students from there. So 32 upon 50 and into, then 31 students will be left to pick from. So 31 upon 49, right? So mathematically, both will come back to 0.52, or these are the two approaches in which you can think. If you had to choose students, like two students, but from different languages, implying one from L1 and other from L2, so you can do the same, like you can pick 18 C1, right? That means, 18 students, or 18 students here and plus 32 from the other plus 32 C1. So that's the possibilities, like that you can combine 18 C1 into 32 C2, 32 C1. So 18 students here, 32 students there, like 18 into 32 are the total possible combinations you can pick one student from both the languages, right? So it doesn't matter whether you pick first from the language 2 and then from the language 1, or the other way around. The point is 18 into 32 are the total number of ways in which you can pick one student each. And total number of ways, like out of 50, to pick two students is 50 C2. If you do that, you will get two students who study different languages, right? So that's the probability of calculating 2 students out of this 50 who happen to study 2 different languages. Right?